रयत शिक्षण संस्था सातारा रोज project 2021-22 for 11th science conducted by Yashwantrao Chavan Institute of Science Satara. Today we are going to learn the last point of our topic, that is rules of differentiation, in which we see addition of two functions and then find its derivative, subtraction, product and division. That is the addition, subtraction, product and division of two functions and how to find its derivative. First one is addition, second subtraction, third we see product, and lastly division. And some examples on it. Theorem first, the derivative of sum of two functions. Then its statement is, if u and v are differentiable functions of x such that y is equal to u plus v, then dy upon dx is equal to du upon dx plus dv upon dx. Here y is the addition of two functions, then its derivative is given by dy upon dx is equal to, take the derivative of u with respect to x plus derivative of v with respect to x. Let's see proof. Firstly, given that y is equal to u plus v, where u and v are the differentiable functions of x, that means the derivative of u and v both are exist, then we say that both the functions are differentiable. Let delta x be the small increment in the value of x, then u changes u plus delta u and v changes to v plus delta v respectively. Correspondingly, y changes to y plus delta y. Here u and v are the functions of x, also y is also function of x. Therefore, if x changes, then u, v and y all are changes. Hence, if the small increment in delta x, small increment delta x in x, therefore u changes to u plus delta u, v changes to v plus delta v, and then correspondingly y changes to y plus delta y. Substitute these values in above equation, that is y plus delta y is equal to u plus delta u plus v plus delta v. Shift y on the right hand side, therefore delta y is equal to u plus delta u plus v plus delta v minus y. Then substitute the value of y is u plus v. Here plus u and minus u get cancelled, plus v minus v get cancelled. Therefore it remains only delta u plus delta v, that is delta y is equal to delta u plus delta v. Then dividing, here is delta x is the small increment in x, म्हणजे delta x ही x मधली small increment आहे, ती व्हॅल्यू 0 नाहीये. जर ही व्हॅल्यू 0 नाहीये तर आपण थ्रू आउट इक्वेशनला डेल्टा एक्स ने काय करू शकतो, डिवाइड करू शकतो. इथे डेल्टा एक्स हवंय, प्रिंटिंग मिस्टेक आहे. देन वी गेट delta y upon delta x is equal to delta u upon delta x plus delta v upon delta x. Then take the limiting value as delta x tends to 0 on both sides. It gives that limit as delta x tends to 0, delta y upon delta x is equal to, take the separate limit to the both functions, that is limit as delta x tends to 0, delta u upon delta x plus limit as delta x tends to 0, delta v upon delta x. Since u and v are the differentiable functions of x, then here we can write limit as delta x tends to 0, delta u upon delta x. This limit is denoted by du upon dx. And second limit as delta x tends to 0, delta v upon delta x is denoted by dv upon dx, and both derivatives are exist. Substitute these both the values in equation 1. Therefore, left hand side is as it is. Here is substitute du upon dx plus dv upon dx. The RHS of equation 3 is exist. This limit and this limit both are exist. Therefore, RHS of that equation is exist. Therefore, the left hand side is also exist. That means that the limit as delta x tends to 0, delta y upon delta x is exist, and this limit is denoted by dy upon dx. Finally, we can write dy upon dx is equal to du upon dx plus dv upon dx. Similarly, we can see the second theorem, derivative of difference of two functions. The statement is almost the same. If u and v are differentiable functions of x such that y is equal to u minus v, then how to find its derivative? dy upon dx is equal to du upon dx minus dv upon dx. आता हे प्रूफ करण्याची गरज नाहीये. ऑलरेडीच्या फर्स्ट थेरम वरून तुम्ही प्रूफ करू शकता. त्याच्यासाठी आता हे आपण प्रूफ घेत नाहीये. वरचा थेरम जो आहे ऍज इट इज असेल, फक्त प्लसच्या तिथे काय येईल, चेंजेस होतील, मायनस साइन चेंज होईल. मग हे तुम्ही प्रूव्ह करू शकता. ओके, लेट्स सी करोलरी ऑन इट. If u, v, w and so on finite numbers of differentiable functions of x such that y is equal to k1 into u plus or minus k2 into v plus or minus k3 into w plus or minus and so on, then how to find its derivative with respect to x? That is dy upon dx is equal to, here k1, k2, k3 are constant. Therefore, right outside k1, take the derivative of u with respect to x, that is du upon dx plus or minus constant k2 is as it is, take the derivative of v with respect to x, then plus or minus k3 is a constant, take the derivative of w with respect to x, that is dw upon dx and so on. म्हणजे ज्यावेळी दोन फंक्शनचे ऍडिशन असू द्या, सबट्रॅक्शन असू द्या, दोन किंवा दोन पेक्षा जास्त फंक्शन्स असेल तर कॉन्स्टंट आउटसाइडला लिहा आणि आहे या फंक्शनचं काय घ्यायचंय, डेरिव्हेटिव्ह विथ रिस्पेक्ट टू एक्स घ्यायचा आहे. हा रूल आपला इन जनरल साठी सांगता येईल. ओके, देन वी सी सम एक्झाम्पल्स ऑन ऍडिशन अँड सबट्रॅक्शन. फर्स्ट एक्झाम्पल इज y is equal to x raised to 3/2 plus log x minus cos x. Okay, write the given function y is equal to same as it is x raised to 3/2 plus log x minus cos x. Differentiate that with respect to x, that is dy upon dx is equal to, take the derivative of right hand side, that is d upon dx x raised to 3/2 plus log x minus cos x. Then separate the derivative for each functions, that is first function, second function and third function. Separate this derivative x raised to 3/2 with respect to x plus derivative of log x with respect to x. Here minus sign. Okay, we can write plus and take the derivative of minus cos x. Write down the minus sign inside the bracket, then take outside. Firstly, we find the derivative of x raised to 3/2. In our first lecture, we see some standard functions and the derivative of that some standard functions. Use this formula. How to find this derivative x raised to 3/2? Here use the formula derivative of x raised to n is equal to n into x raised to n minus 1. Therefore, its derivative x raised to 3/2 is 3/2 into x raised to 3/2 minus 1, that is x raised to 1/2 plus derivative of log x is 1/x. Write down as it is. Here minus sign take outside and the derivative of cos x is minus sin x. Therefore minus into my bracket minus sin x. minus minus is plus. Then finally we can write 3 upon 2 x raised to 1 by 2 means root x plus 1 by x, minus minus is plus sin x, and this is our answer. Second example, if f of x is equal to p tan x is equal to q sin x plus r, and it is given the three conditions: f of 0 is equal to minus 4 root 3, second is the f of pi by 3 is equal to minus 7 root 3, and third condition is the f dash of pi by 3 is equal to 3. In first two condition, it is given that the value of function at x is equal to 0 and x is equal to pi by 3. And in third condition, the derivative of given function at x is equal to pi by 3. Okay, let's see its answer. Then here we want to find the value of p, q and r. Here p, q, r are unknowns. Write the firstly given function f of x, say equation first, then find its derivative. F dash of x is equal to p sec square x plus q cos x. Here p is a constant multiple of tan x, therefore p as it is, the derivative of tan x is sec square x plus q as a constant multiple, write down as it is, the derivative of sin x is cos x, and the derivative of r, that is constant, derivative of constant is 0. First condition, write down f of 0 is equal to minus 4 root 3. Put in equation 1 x is equal to 0. That is, we get f of 0 is equal to p into tan 0 plus q into sin 0 plus r. Here tan 0 is 0, sin 0 is 0. Therefore, first and second is also 0. It remains only r, but here the value r is equal to f of 0, and the value of f of 0 is minus 4 root 3. That means that r is equal to minus 4 root 3. It is given the first value. It gives first value r is equal to minus 4 root 3. Here second condition, f of pi by 3 is equal to minus 7 root 3. Put x is equal to pi by 3 in equation 1. We get f of pi by 3 is equal to p into tan pi by 3 plus q into sin pi by 3 plus r. Pi by 3 means 60 degree angle. Here tan 60 is root 3, sin 60 is root 3 by 2 plus r is as it is. Here substitute the value of r is minus 4 root 3 is equal to minus 7 root 3. Therefore, it gives multiply, taking common root 3 get cancelled. Then multiply this equation by 2. We get 2p plus here 2 get cancelled. Only it remains q minus 4 into 2. That is 8. Here minus 7 into 2, 14. 14 minus 14 plus 8, that is minus 6, and say this equation is 3. And last, use the condition f dash of pi by 3 is equal to 3. Put x is equal to pi by 3 in equation 2. We get p sec square pi by 3 plus q cos of pi by 3 is equal to 3. Here sec square of 60 degree plus cos of 60 degree is equal to 3. 4 into p, sec 60 is 2, square of 2 is 4, therefore here is 4p plus q into cos of 60 is 1 by 2, that is q by 2 is equal to 3. Multiply throughout equation by 2, that is 8p plus q is equal to 6. Say equation 4. Subtracting equation 3 from equation 4, we get 6p is equal to 12, that is p is equal to 2. and put this value in equation 3, we get q is equal to minus 10. Finally, r is equal to minus 4 root 3, p is equal to 2, q is equal to minus 10, and r is equal to minus 4 root 3. And this is our answer. Our third theorem, derivative of product of two functions. Firstly, see statement, if u and v are differentiable functions of x such that y is equal to u into v, then here y is a product of two functions. U and v are the functions of x, and here it is given that u and v are separated by product. म्हणजेच काय, या दोघांच्या मध्ये प्रोडक्ट आहे, तर असं असेल तर आपण डेरिव्हेटिव्ह कसं फाइंड आउट करायचंय. देन dy by dx is equal to first as it is u say as a first term, v second as a second term. Therefore first term as it is, take the derivative of second with respect to x, that is dv upon dx, plus second as it is v as it is, take the derivative of u with respect to x, that is du upon dx. How to prove? As similar to theorem 1 and theorem 2. Given that, firstly write the given function y is equal to u into v, where u and v are the functions of x. Let delta x be the small increment in the value of x, then u changes to u plus delta u. जर x ची व्हॅल्यू x मध्ये हा डेल्टा x स्मॉल इन्क्रीमेंट घेतला तर बाकीच्या मध्ये चेंजेस काय होतील, u मध्ये काय चेंजेस होतील, u प्लस डेल्टा u. v मध्ये काय चेंजेस होणार, v प्लस डेल्टा v. आणि u आणि v मध्ये चेंजेस होत असतील तर करस्पॉन्डिंगली y मध्ये चेंजेस जे होतील त्याला काय म्हणायचं, y प्लस डेल्टा y. ओके, write down here y plus delta y is equal to u plus delta u into v plus delta v. Here y shift on the right hand side, minus y, then put the value of y is u into v. Take the product of these two bracket, it gives that u into v, here plus uv and minus uv get cancelled. It remains only u into delta v, here is the function v into delta u as it is, plus delta u into delta v. I think इथे एक टर्म मिसिंग आहे. नेक्स्ट टर्म काय हवे, प्लस डेल्टा u into delta v. As delta x is the small increment in x and delta x is not equal to 0, then dividing throughout equation by delta x. Here not only x, delta x. Therefore, we can write delta y upon delta x is equal to u into delta v upon delta x plus v into delta u upon delta x. And here is a missing term, delta u into delta v. Write down here, delta u into delta v divided by x. Taking limit as delta x tends to 0 on both sides, we get limit as delta x tends to 0, delta y upon delta x is equal to limit as delta x tends to 0, delta u upon delta x. I think here is v function राहिलेला आहे. Limit as delta x tends to 0, delta v upon delta x plus limit as delta x tends to 0, delta u upon delta x, right outside the delta v, and taking as delta x tends to 0, then delta v is also tends to 0. म्हणजे जर डेल्टा एक्स ची व्हॅल्यू 0 ला अप्रोच होत असेल तर डेल्टा v ची सुद्धा व्हॅल्यू कुठे अप्रोच होईल, 0 लाच अप्रोच होईल. Therefore the limit as delta x tends to 0, delta y upon delta x, write down the both the functions. Here limit as delta x tends to 0, delta x tends to 0 is replaced by delta v tends to 0. Since u and v are the differentiable functions of x, then we can write the derivative of this function is represented by du upon dx and derivative of that function is represented by dv upon dx. From using equation 1 and 2, we can write limit as delta x tends to 0, delta y upon delta x. Here the missing term v, and here u. That is u into that term is denoted by dv upon dx plus that term is denoted by du upon dx into v. आता इथे डेल्टा v टेन्स टू 0 आहे. जर मी या फंक्शन मध्ये डेल्टा v टेन्स टू 0 अप्लाय केला तर 0 into that term is 0. Therefore the derivative limit of that last term is 0. And it remains only two terms, that is u into dv upon dx plus v into du upon dx. RHS of equation 3 is exist. Therefore, the left hand side is also exist. Hence, we can write limit as delta x tends to 0, delta y upon delta x is exist, and it is denoted by dy upon dx. Finally, we write the statement dy upon dx is equal to u into dv upon dx plus v into du upon dx. Similarly, also see the quotient rule one by one, and then we'll see the examples on product and division. Our fourth theorem is derivative of quotients of two functions. See the statement. If u and v are the differentiable functions of x such that y is a division of two functions, that is in the form of u upon v, then dy upon dx is equal to u is a numerator, v is a denominator. Then its derivative is given by v into du upon dx minus u into dv upon dx upon v square. That is denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. Okay, let's see the firstly proof. Given that y is equal to u upon v, where u and v are the functions of x, as delta x is the small increment in the value of x, then u changes to u plus delta u, v changes to v plus delta v respectively. Therefore, the correspondingly increment in y, say y plus delta y. Therefore, we write the given function y plus delta y is equal to u plus delta u upon v plus delta v. Shift y on the right hand side, that is minus y. Then put the value of y is u upon v. Okay. See here u upon v. Then take the cross multiplication of these two functions. V into u plus delta u minus u into v plus delta v divided by v into bracket v plus delta v. Then multiply by v inside the bracket, multiply by minus u inside the bracket. It gives v into u plus v into delta u minus u into v plus and minus minus u into delta v as it is, v plus delta v into v as it is. Here u into v plus, and here is plus and here is minus, both get cancelled. Then remains only two terms, that is here is plus term, then here is minus term. That is delta y is equal to v into delta u minus u into delta v divided by v plus delta v into v. Then dividing both side by delta x, as delta x not equal to 0, delta x is small increment x मधली आहे, तर डेल्टा x ची व्हॅल्यू 0 नाहीये, म्हणून बोथ साइडला काय करू शकतो आपण, डेल्टा x ने डिवाइड करू शकतो. इथे प्रिंटिंग मिस्टेक आहे, फक्त x लिहिलंय, से एज अ डेल्टा x. Therefore, the above equation becomes delta y upon delta x is equal to v into delta u minus u into delta v divided by delta x into v plus delta v into v. आता इथे डेल्टा एक्स ने बोथ टर्मला डेल्टा एक्स ने डिवाइड करायचं, सेपरेट डिव्हिजन अप्लाय करा. डेल्टा एक्स ने डेल्टा यू ला सुद्धा डिवाइड केलं, डेल्टा व्ही ला सुद्धा डिवाइड केलं, तर फंक्शन काय येईल, v as it is delta u upon delta x minus u as it is delta v upon delta x. Then the denominator is multiplied by v, that is v into v, v square, v into delta v. Then taking the limit as delta x tends to 0, take the left hand side limit, sorry, limit as delta x tends to 0, delta y upon delta x is equal to limit as delta x tends to 0 whole term, and then separate the limit for each term. As delta x tends to 0, then delta v also tends to 0. Here separate the limit v as it is, derivative limit as delta x tends to 0, delta u upon delta x minus u into limit as delta x tends to 0, delta v upon delta x divided by v square plus v right outside, and delta v upon delta, sorry, delta v limit as delta x tends to 0. Since u and v are both functions of x, therefore their derivative is exist, that is limit as delta x tends to 0, delta u upon delta x is denoted by du upon dx, and the second derivative limit as delta x tends to 0, delta v upon delta x is equal to dv upon dx. From equation 1 and 2 we can write, substitute these limits, represent this limit as a du upon dx and second limit as a dv upon dx. Using these two equations, the equation first can be written as, write down here du upon dx, then here dv upon dx, and here delta v tends to 0. As delta x tends to 0, delta v also tends to 0. Okay, write down here, as delta x tends to 0, then delta v also tends to 0. Therefore, this limit tends to 0 and denominator remains only v square. Okay. See, here v into 0. Above limit is denoted by du upon dx and second is dv upon dx. The right hand side of above equation is exist, therefore left hand side is also exist, and it is denoted by, this limit is denoted by dy upon dx. Finally, we write the theorem, dy upon dx is equal to u into du upon dx minus u into dv upon dx upon v square. This is our quotient rule. Then we see examples on product and division. First one is the function f of x is equal to x raised to 5 into cosec x plus root x into tan x. Firstly, write down the given function as it is, f of x is equal to whatever it is. Second, here function is y is equal to e raised to x minus 5 upon e raised to x plus 5. Then third is the y is equal to x into sin x upon x plus sin x. Okay, let's see the firstly solution of first function f of x is equal to, it is given that the function f of x is equal to x raised to 5 into cosec x plus root x into tan x. Differentiate that equation with respect to x. Here x raised to 5 is a u function, cosec is the v function. Second term is also u into v because root x is the u function and tan x is the v function. And here it is given that the product of two functions. F dash of x is equal to derivative of whole term. Here the firstly derivative is separated by plus sign because here given that the addition of two functions, and in addition of two functions derivative can be separated, therefore take the derivative of x raised to 5 into cosec x with respect to x and derivative of root x into tan x with respect to x. Then use the product rule for both functions. Here x raised to 5 as it is, derivative of cosec x plus cosec x as it is, derivative of x raised to 5 plus. Okay, also similarly take the derivative of second term, root x is as it is, derivative of tan x plus tan x as it is, derivative of root x. One by one find its derivative. X raised to 5 as it is. Derivative of cosec x is minus cosec x into cot x plus cosec x as it is. Derivative of x raised to 5 is 5 into x raised to 4 plus root x as it is. Derivative of tan x is sec square x plus tan x as it is. Derivative of root x is 1 upon 2 root x. And finally write the our answer. Take the minus sign outside. X raised to 5 into cosec x into cot x plus 5x raised to 4 cosec x plus root x into sec square x plus 1 upon 2 root x into tan x. This is our first solution. Okay, let's see second. Given that y is equal to e raised to x minus 5 upon e raised to x plus 5, differentiate that equation with respect to x. Therefore, left hand side is dy upon dx is equal to derivative of given function. It is given that the division of two functions. The numerator is e raised to x minus 5 and denominator is e raised to x plus 5. Directly apply the division rule. Denominator as it is e raised to x plus 5 as it is into derivative of e raised to x minus 5 minus e raised to x minus 5 as it is derivative of e raised to plus 5 divided by denominator square, that is e raised to x plus 5 bracket square. Here e raised to x plus 5 as it is, derivative of e raised to x is e raised to x. The derivative of minus 5 is 0 because the derivative of constant is 0. Minus e raised to x minus 5 as it is, derivative of e raised to x plus 5 is e raised to x and the derivative of 5 is 0. Denominator is as it is, e raised to 2x multiplied by inside the bracket is e raised to x, e raised to 2x plus 5 into e raised to x minus e raised to x into e raised to x, e raised to 2x. Here minus minus plus 5 into e raised to x divided by e raised to x plus 5 bracket square. Here e raised to 2x and e raised to, sorry, plus e raised to 2x and minus e raised to 2x get cancelled. It remains only 5 plus 5, 10 e raised to x divided by e raised to x plus 5 bracket square. And third function is y is equal to x into sin x divided by x plus sin x. Differentiate that equation with respect to x. The left hand side derivative is denoted by dy by dx and right hand side derivative of given function with respect to x. Same use the formula for division of two functions, x into sin x as it is into derivative of, sorry, here x plus sin x, denominator as it is, x plus sin x as it is, take the derivative of numerator, that is x into sin x minus x into sin x as it is, derivative of x plus sin x divided by denominator square, that is x plus sin x bracket square. X plus sin x as it is, the derivative of x into sin x. Again use the product rule here because x is a function of x, sin x is also a function of x, and in which it gives given that the product of these two functions. Therefore, how to find its derivative? By using the product rule, that is x as it is derivative of sin x plus sin x as it is derivative of x minus x into sin x as it is derivative of that function. The derivative of x is 1 and the derivative of sin x is cos x divided by denominator as it is. X plus sin x as it is, x as it is derivative of sin x is cos x, sin x as it is derivative of x is 1 minus x into sin x, 1 plus cos x as it is, and denominator is also as it is. Here multiply, take the multiplication of these two bracket, x into x, x square cos x plus x into sin x plus x into sin x into cos x plus sin x into sin x sin square x. Similarly, minus x into sin x as it is. Here plus and minus minus x into sin x into cos x as it is, and denominator is also as it is. Here x into sin x cos x plus, and here is minus x into sin x into cos x is minus. Therefore, both the terms are get cancelled, and finally we get x square cos x plus sin square x, and one more also term get cancelled, x into sin x. Here minus x into sin x, both are get cancelled. Therefore, these two terms are remains, and denominator is also as it is, x plus sin x bracket square. Okay. Okay. Here our topic is completed, and thanks for watching. Thank you. Thank you so much.